Hi again, Captain Peter Cutsey with another of my online briefings for the 737. And today our topic is one of the most important in the initial flight training part of a course, is the approach to stall recovery. Let's look at the objective. The objective of the approach to stall or stall recovery training is to familiarize the pilot with the stall warning and correct recovery techniques. Recent safety studies have shown that an increasing number of stall-related accidents have occurred during the maneuvering and approach phases of flight. In an effort to reduce this trend, training emphasis has shifted to performing stall or stall recovery exercises in the phases of flight listed below. Approach to stall or stall recovery training maneuvers should be done under simulated instrument conditions with the autopilot engaged. Incidentally, these aren't my words, these are the words from the aircraft manufacturer directly from the FCTM. And I might add that anything that comes out of my mouth is directly from the Boeing manuals, and this is what instructors should be using. The exercises include high level, stall, level off, stall, turning base, stall, and ILS final approach. These terms are out of the FCTM. The autopilot slowly establishes a pitch attitude by using stabilizer trim and or elevator position to induce the stall buffet or stick shaker. During the initial stages of the stall, local airflow separation results in buffeting, giving a natural warning of an approach to stall. Stall warning should be readily identifiable by the pilot, either by initial buffet indication or an artificial indication, such as a stick shaker. So before we get into more information on what we would do in the lesson, I want to speak about three critical angles, which are the pitch angle, flight path angle, and angle of attack. Two of these are not really understood by most people, so let's me stop sharing my screen here just for a moment. We're going to go to my iPad and we'll have a look at that. And just to, here we are, to make this simple, we know what a pitch angle is. The pitch angle is the difference between the aircraft longitudinal axis and the horizon. That's fairly simple. That's the pitch angle between the aircraft longitudinal axis and the horizon. The next angle to understand is a flight path angle. And looking at what we have here on an IL, a good way to represent this is have a look at what I've got here for an ILS. On an ILS, 3-degree glide path, uh, your flight path angle, by the way, the definition of a flight path angle is the angle of the flight path with respect to the horizon. So an easy way to think about this is on a 3-degree glide path, your flight path angle is minus 3 degrees. That's fairly simple. Here we are here. The aircraft, this little yellow symbol, may be pitched up at, let's say for simplicity's sake, plus 2 degrees at flaps 30 on an ILS approach at max landing weight for the 737NG. So you're pitched up at plus 2 degrees, and the actual flight path angle is minus 3 degrees. So the angle of attack is the difference between the aircraft pitch angle and the aircraft flight path angle. And that happens to be 5 degrees. Minus 3 on the flight path angle and a plus 2. So the difference between these is 5 degrees. So let's go to another picture. In level flight, you're not climbing, you're not descending. Here we are with a pitch of +6 degrees. Let's say it flaps 5 downwind on a traffic pattern. Your flight path angle is 0. The angle between your the flight path angle and the horizon is 0. The angle of attack is the difference between the pitch angle and the flight path angle, which is +6. So the angle of attack is +6 in level flight. All right, let's go back and we'll share another part of the screen here. Now that we understand what we are doing with respect to that. So now we will share with the screen. So now we're back sharing with the screen for the PowerPoint presentation. Get the annotate menu back up here. So now that we understand the 3 critical angles, let's go ahead to recognize and confirm. Recognizing stall, warning, stick shaker, buffeting, which could be heavy, lack of pitch authority, lack of roll control, and inability to arrest the descent rate. This is a good picture here. Remember, the trend arrow is letting you know what the airspeed is going to be in the next 10 seconds. So that is a very important part of the flight instrument system. We'll jump out of this PowerPoint and go to the FCTM, which has, we're looking at 12 pages in the FCTM, which has a lot of excellent information with respect to the stall or approach to stall. And you should study this, and your instructor should brief you on this. A stall warning should be readily identifiable by the pilot either by initial buffet, as we just mentioned, or an artificial indication such as a stick shaker. During the initial stages of stall, local airflow separation results in buffeting, the initial buffet, giving a natural warning of an approach to a stall. Okay. Now, an airplane is characterized by one of the following conditions. Stall warning, an airplane stall, that is. Stall warning, buffeting, which could be heavy, lack of pitch authority. In other words, moving the pitch as far as pitching down or pitching up has very little effect. You don't have full control of the elevators. And lack of roll control, likewise on the ailerons and spotters. The rolling sensation is very sloppy. And an inability to arrest descent rate. You can't stop the descent. These indications are indications that an airplane stall is characterized by, all right? To initiate the recovery, the angle of attack must be reduced below the wing stalling angle of attack. All right, the angle of attack. We talked about that. We already looked at that, so now that you understand that. So we do that by unloading the elevator, that is by pitching down. We use the term unload because in the upset recoveries, this is a new term to allow us to understand to pitch forward using elevators. And in some cases, aiding the pitch down with nose down trim on the stabilizer. And smoothly applying nose down elevator to reduce the angle of attack until the wings are installed. Now, there's a comment here, nose down stabilizer trim may be needed if control column does not provide the actual response. So because the controls are so sloppy, you may need the assistance of the horizontal stab. Application of forward control column as much as full forward may be required. And the use of some nose down stabilizer trim should provide sufficient elevator control to produce a nose down pitch rate. Here again, here's that term unloading, unload. Unloading the wing. Unloading means relaxing on the back pressure and pitching down using elevator nose down moment. By maintaining continuous nose down elevator pressure, keeps the wing angle of attack low, making the normal roll controls more effective. Use care during recovery from a nose low attitude after the buffet and or stick shaker have stopped. If the pull-up is too aggressive, a secondary stall or a sustained stick shaker may result. Remember, the whole part of this exercise approach to stall is for training only. You should never be below the bug speed, ever, ever. If you are, it means you're not doing your job. Or situations such as wind shear has caused something, even though you are attentive, and you've got to respond immediately. So what we're going to do in training, in the training exercise, and your instructor is going to do, is he's going to mention that this is for training purposes only, so that you can actually recognize and confirm what you would see approaching a stall. And for the training purposes, we're going to go right through to the stick shaker. I'll brief you on that in the simulator again. In the real world, you would never get close to a stall if you're doing your job properly. All right. Uh, we have different recoveries. One is a high altitude recovery, and it's normally done above 20,000 feet. Remember, we talked about four types of approach to stall recoveries: a high altitude recovery and a level off recovery, which we're going to initiate at 10,000. I'll go through that in a minute with you. And then turning base recovery, which we're actually going to do in the traffic pattern close to the ground. And then an ILS final approach recovery, which we're actually going to do under IFR conditions on an ILS. And it's important that your instructor follow these instructions directly from the FCTM. We'll look at them shortly. All right. So the entire part of this FCTM is important that you read it and understand what you can expect. We've already looked at that part of it, and we'll go down to the actual setup, and this is all from the FCTM for the high altitude recovery, which your instructor will put you up at the probably the maximum altitude for your weight. And it could be, for that exercise, it could be flight level 350. And basically, if an approach to stall indication is experienced, nose down elevator and stabilizer trim is required to initiate a descent. This is because when the airplane is thrust limited, which you are at high altitude, altitude needs to be traded for airspeed. And above all, you're not trying to maintain an altitude. Remember, in all these practice to approach stall recoveries, the intention is not to maintain an altitude, but to get the airplane flying safely, and you will incur and you must accept an altitude loss. At high altitude, at flight level 410, it could be as much as 10 times greater than that at low altitude. Low altitude, you may lose 400 feet approximately as you recover properly and to get the aircraft flying. You can expect that to be close to 4,000 feet at, say, flight level, above flight level 350. And your instructor will demonstrate that to you. The approach to stall recovery, the level off type stall, right here in the FCTM, and you should read it, and we'll go through that in a moment in my PowerPoint. Everything we're doing in this briefing is right out of the book. The turning base stall, so you actually set up turning base in IFR conditions, and then the ILS final approach stall. So all of this information in the FCTM is of utmost importance. So we talked about that. Now let's go to the setup for the level off stall. These instructions are primarily for the instructor who's going to be giving this lesson. Reposition the aircraft at 10,000 feet. Clean, flaps up speed, all AFDS engaged. Clear the crew to descend to 9,000 feet with the clearance to expedite descent, which will trigger them to use level change and speed brakes. When the thrust is reduced, you, as the instructor, will disengage the auto throttle. Ask the crew to leave the speed brakes extended on level off for the entry to the approach to stall. This is training only. Ask the crew to go through to the stick shaker. And as the crew are doing that, point out the trend speed indicator, point out the amber band, the approaching the amber band, which is the minimum maneuvering area, and also point out the fact that when you actually pass through, halfway through the minimum maneuvering band, that you will get airspeed low, some aircraft may not. But in any case, point these things out to the students so that they're aware of what they can expect, and reiterate the fact that you want them to go through to the stick shaker, and ask the pilot monitoring to actually check the angle of attack on the HUD, or actually check the pitch angle. Remember, in level flight, we saw that before. In level flight, the flight path angle is 0, and the angle of attack is the difference between your pitch and the flight path angle. So you'll find that you'll start to get the shaker, let's say at 60 tons, I should say, 60,000 kilograms. So you'll be at that weight. You'll probably get the stick shaker around 12 degrees, 11 to 12 degrees of angle of attack. Don't memorize this. I'm just telling you this to know what to expect. So you're going to have close to 12 degrees of pitch, which is angle of attack in level flight. All right? So as a pilot monitoring, point that out to your pilot monitoring. And then when you switch seats later in the last half of the session, you can point that out again to the new pilot monitoring. Ensure that the crew would normally take an action at the first recognition of any symptom in the real world. But for this exercise only, we'll go through to the stick shaker. So you're approaching the stall, and there's the amber band, as I was saying. And when the airspeed is actually halfway through the amber band, you will get airspeed low. An oral warning, airspeed low. And incidentally, the window around the airspeed will change from white to amber as you come into the amber band, and flash as a reminder to get your attention. And at this particular point, you'll be getting the stick shaker. All right? Remember, this is for training only. So now let's go with the recovery of this level off type stall. Recovery from the level off stall as follows. This is not my mouth. This is right in the QRH, which we'll look at shortly, and the FCTM. Hold the control column firmly. Disengage the autopilot and auto throttle simultaneously. Smoothly apply nose down elevator, the term we use nowadays in the upset recoveries is unload, which is check forward on the control column to reduce the angle of attack until buffet or stick shaker stops. Nose down stabilizer trim may be needed. Don't necessarily use it unless you need to use it. Your instructor will tell you. Roll the shortest direction to wings level if needed. Advance thrust levers as needed. Retract speed brakes. Do not change gear or flap configuration except during liftoff. If flaps are up during liftoff, call for flaps 1. Number 7, check the airspeed and adjust thrust as needed. Establish a pitch attitude. Return to the desired flight path. In this case, you were cleared to maintain 9,000 feet. We leveled off at 9,000 feet, and we entered the approach to stall. So you've lost so many feet. You've got to come back to 9,000 feet, and then back to the speed on entry. Your instructor will actually set you up at flapped up speed on the entry. So re-engage the autopilot and the auto throttles if desired. Now remember that as pilot flying, uh, a good way to set up the AFDS system is rather than engage the autopilot first and take your scan focus away from flying to make your selections on the MCP, ask the pilot monitoring to make the selections on the MCP from left to right with the auto throttles and speed and a pitch mode and a roll mode. And then lastly, you select your autopilot. That way you're focusing on flying the airplane. That's a technique that works well. I've been using it for many, many years, about 50. In any case, it worked well. So follow this recovery procedure and everything will work the way it should. And we'll have a look at that shortly. And here are some pictures during the recovery as the airspeed trend is increasing, as you're increasing thrust, of course, and accelerating mode, and you can call for the AFDS requirements as I just mentioned. All right, that is a level off type stall. The next would be a turning base type stall. Your instructor will actually set you up downwind, reposition the aircraft downwind at an instrument vectoring altitude for the ILS. You can get that from your approach chart. And the in the flaps 5 mode with all AFDS engaged, autopilot and auto throttles engaged, and at flaps up speed. Now, then unfreeze the simulator and give the students control, and then as they're proceeding to a point where you're going to vector them to base leg, disconnect the thrust levers closed and disconnect the auto throttles. The instructor will do this. Then give a turn immediately to a 90-degree downwind. And the crew will follow the heading and they will go to the stick shaker as briefed and recover as briefed. So here's the recovery, the same as before. Hold the control column firmly, disengage the autopilot and auto throttle simultaneously, smoothly apply nose down elevator, that is unload to reduce the angle of attack until buffet or stick shaker stops. At that point, the airplane's flyable. Now you can roll the shortest direction to wings level if needed. And remember, don't try to maintain your altitude. Just get the airplane flying. Once it's flying, you can regain your altitude. Advance thrust levers as needed. Do not change gear or flap configuration. Very important. Check airspeed and adjust thrust as required. Establish pitch attitude. Return to the desired flight path, that is the heading that you were assigned and the altitude for base leg. And re-engage the autopilot and auto throttle if desired. And remember how to do that. Remember, as pilot flying, you select your autopilot only. So select it last, ask the pilot monitoring to make all other selections, auto throttle, pitch mode, roll mode, and then you select the autopilot. The ILS final approach stall, your instructor will set you up. He'll have you dial in an ILS, reposition the aircraft on a 6-mile final. I find this works great. And of course, set the weather to perhaps a 200-foot ceiling. So have the crew configure the aircraft for landing at flaps 30 with all AFDS engaged and setting the weather to 2,600 feet, the RVR and the ceiling 200 feet. And then unfreeze the aircraft. Disengage the auto throttle once the crew are established on final. And the crew are to recover on the stick shaker as briefed. Ensure they recover from the stall first, using sufficient thrust to accelerate to VREF while climbing before initiating a go-round. Very important that you recover from the stall first. You should get a GPWS. You still have to recover from the stall first. Then look after the GPWS. And then when at VREF, you go through the go-round procedure. So the recovery is hold the control column firmly, disengage the autopilot and autothrottle, smoothly apply nose down elevator, unload to reduce the angle of attack until buffet or stick shaker stops. Roll the shortest direction to wings level if needed. Advance thrust levers as needed. Now remember, uh, as you're descending and you want to accelerate through to VREF, if you put on full thrust, the aircraft is going to pitch up accordingly, and you'll never end up accelerating to VREF. So when you do apply thrust and pitch up, restrict your rate of climb to something, I'm saying between 500 feet and 1,000 feet a minute, but no less than 500 feet a minute, so that you can actually accelerate as you're climbing. You've got to climb, and you've got to accelerate. Otherwise, you'll never get to VREF. Once you've accelerated to VREF, you can initiate the go-around procedure. Go around, flap 15, positive rate, gear up, whatever. Go-around procedure is very important that both pilots ensure the go-around has been selected, TOGA is enunciated, go-around and TOGA has been enunciated, that the aircraft has actually pitched up before you call for flaps 15, and make sure all of that is set up. Then pilot flying call for flaps 15. Then pilot monitoring call positive rate. Then pilot flying call for gear up. The go-around procedure is very important and hasn't been accomplished properly in many incidents and accidents in history. So ensure that you do it methodically and both people watch that you get the correct FMA indications before you rush into calling for flaps 15. All right, so back to the main menu, and that is basically what we would cover, or your instructor will cover, in the lesson of approach to stall recovery. I hope you enjoyed the briefing. And remember those 3 critical angles, the little pictures I showed you. Stay passionate, study a lot before you go flying, and stay professional. I'll see you on the next briefing.